Okay, and let me take paint. So guys, yes, DHCP, dynamic,
Host configuration.
yes, host configuration protocol. Dynamic host configuration protocol. Now let me tell you about this DHCP. Okay, I might have told you about a DHCP server. Okay, so the DHCP server, or say suppose if you have multiple computers in your office, then suppose all the computers are connected to the switch. Sorry, if all the computers are connected to a switch, now if at all this network here, it is 10.0.0.0/24. Now if you have 100 computers or 200 computers, say you will have to give the IP address manually, .1, .2, .3, .4, etc. You need to give it manually. Instead, what you're going to do is you're going to give the IP address to the computers using a server. Okay, and this server is called DHCP server. So instead of giving the IP address manually, we are having one server called DHCP server. With the help of the DHCP server, we will dynamically allot, or we will dynamically assign IP address to the computers. So we don't have to assign the IP address. The DHCP server will will dynamically assign the IP address to the computers. Clear? Okay. Now let me tell you the process here. Suppose this machine, a new machine has come. If the new machine has come, and of course if he is connected to a network, he needs an IP address. So if he needs an IP address, what he will do is that he will send a message, a broadcast message, that's called discover. It's called discover message. It is sent to discover the DHCP server. It is sent to discover the DHCP server. So what happens is that he will send a broadcast message and it will be sent to all the interfaces. Okay, and now the concerned machine, say he will be sending it. Okay, and it will be sent to all the interfaces. It will be sent here, everywhere, and the DHCP server will reply back. And this reply, it is called offer. What is it called? Offer. So offer, it's also a broadcast at the layer 3 and layer 2. Okay, so the offer message, this message consists of the related parameters. The related parameters means say this client machine. So this is the client machine and this is the server machine. So the client machine, he is sending a discover message to discover the DHCP, and he'll be asking an IP address. So the DHCP server will offer him an IP address and the related parameters, say the IP, the subnet mask, the default gateway, etc., the DNS IP, etc. Okay, so along with this offer message, the DHCP server will send the IP, the subnet mask, the default gateway, DNS value, etc. Okay, now the computer will receive it. And computer, what he will do is that the client will again send back another message called a request. This message is called a request. So if at all you have different DHCP servers, and if different DHCP servers has sent, say all the server might have received and discover from this computer, and the server will send back an offer. Okay, then this computer or the client computer will send a request back, so to confirm that, say he has selected this specific DHCP server and he has accepted his offer. Clear? So that's why the request is sent, to notify that the respective IP address has been selected from this server. Okay, I'll be using so and so IP provided by you. That's what the request says. And say in response for that, the DHCP server, the concerned DHCP server will send back an acknowledgement. Okay, so these are the four messages, four important or four say basic level DHCP messages: discover, offer, request, and acknowledgement. So discover is sent by the client to the server, offer from the server to the client, and request client to the server, and acknowledgement server to the client. Clear, guys? Okay. Now, so today we'll be studying how you can configure the DHCP server, not in the server machine, but in the router. In the router. Okay. You can configure the DHCP service in the router also. So how will you configure that? That's what we are going to discuss. Okay. So let me take a topology here.
What is the best practice?
It's always better to have a different DHCP server itself. Okay, in the companies, in the say production environment where you have larger number of machines, you will assign different things to different servers. So it is always better if you have say if your environment is big, then it's always better to have a different DHCP server. But if your environment is small, then no need to give an extra DHCP server. Even in your home network and all, your router itself, your Wi-Fi router or your say whatever it is, the modem. So that consists of the DHCP server. Okay, in the small environments, that is enough. Okay, so now, just give me a moment. Okay. Yes. Suppose that okay. So this is the network, suppose. Not this one. Suppose this is the network. Okay. Here consider this is the LAN. Here we got lot of machines. We got lot of machines and computers. Okay, and these computers need to receive an IP address from this DHCP router. Okay, so this is the DHCP router in which we'll be configuring the DHCP services. Okay, so now suppose that we need, or say here, okay, let it come. Yes. So now here you got a network here. The network is 192.168.10.0/24. So when you have the computers here, all the computers require this IP address. Right. IP address of the range 192.168.10.0/24 range. Okay. So what we are going to do is we are going to create the DHCP service in this router, and we are going to create a pool here in the DHCP. We are going to create a pool. And in the pool we will mention what is in the network which needs to be given, in which network say the computers should be receiving this IP. Clear, guys? Okay, so let me take this DHCP. So here I have already assigned 192.168.10.1 for this router. Okay, 10.1/24 for this router. So and now let me take the console of the router. So show IP interface brief. I've already configured an IP address in fastnet 0/0, which is 192.168.10.1. Okay. Now let me go to the config mode, and now we are going to configure the router as a DHCP server. Okay. The command is simple. Say we'll mention it like this: IP DHCP pool. Then we'll give a pool name. Any name you can give. Okay. Suppose test pool. Okay, then you can see you are moved into the DHCP. The prompt has now moved into the DHCP. The prompt is DHCP-config. Then we will give the pool here, or the network. The command is like this: network. Okay, then we'll mention the network here. So here, when all the computers request for the IP address, we should assign an IP of the network 192.168.10.0/24. So we'll give that network 192.168.10.0/255.255.255.0. Okay, then after that what we are going to do is we'll give the default gateway. Of course, this computer need to have a default gateway. Only if the default gateway is received, then you will be able to communicate to the outside world, right? So we will mention the default gateway. For those computers, you need to mention the default gateway, which is the router's IP. So the router's IP is 192.168.10.1. And if you have a DNS server, you will give the DNS server's IP. Suppose the DNS server's IP is 192.168.10.100 is the DNS server's IP. Okay, your local DNS IP. Then you will give the DNS server's IP. Clear? Then if you want, you can give the domain name as well, the domain name for the computers. Okay, so the domain name will be given like this, domain-name. Then you will give the domain name. Usually in whichever company you work, that will itself will be the domain name. Suppose you are working in cisco.com, then you will be giving the domain name as cisco.com. Clear? Any doubt in this one? Now what we are going to do is, suppose here, so whenever the computer, this PC asks for an IP address, okay, so he will send a discover, and the DHCP will receive the discover, and he will send back an offer. Okay, now this offer we have mentioned to the router that they have to start, or they have to give an IP of the range 192.168.10.0/24. So he will first give .1 here, but .1 is already assigned to the router, so it should not be given to the computer. So you can exclude it. You can exclude it from the DHCP pool so that it will not be given to the computer. Okay, so to exclude it, we will go to the DHCP, we will go to the config mode, and the command is IP DHCP excluded -address. Then we will mention the address 192.168.10.1 and say we have another value here. DNS server is also assigned with 192.168.10.100 manually, maybe. So then you need to exclude that address as well. .100. Clear? So this is how you will exclude the IP addresses. Okay. Now this router will act as a DHCP server. Now suppose that if at all the computer want to receive an IP address through the DHCP server, we will go to the respective interface, or we'll go to the respective adapter. So we'll take the network connections, and then we'll click on to the required one. Okay, just give me a moment. Yes. Okay, we'll click on to this respective adapter. Suppose this is the adapter through which I need to receive an IP address. Okay, I'll click on to the respective adapter, then I'll take this IPv4, and then I'll click on to this one. Use the following. Not this one. I'll click on to this one. Obtain an IP address automatically. Then if I click OK and again OK, and if at all the cable is all connected and all, this computer is gonna send the discover message. Clear? Now in the GNS3, what I'm gonna do is I'll go to the PC1. Okay, in the GNS3 I'll go to the PC1, and then what I'm gonna do is I'll mention like this, IP DHCP. Okay, I'll mention IP DHCP, then the computer is gonna send a discover. Okay, so here you can see they are sending the discover message, and in response they are receiving the offer request. So the DORA process is complete and it has obtained an IP. What is the IP? 192.168.10.2/24, and the gateway address is 192.168.10.1. Any doubt? So this is how the computers receive an IP address from the DHCP. Okay, now the next one. The next one here, suppose you got a client router. Okay, so till now we have been configuring an IP address in the interface of the router. Suppose what if the computer or the router needs to receive an IP address from the DHCP server. Okay, so this router, the client router here, needs to receive an IP address from the DHCP server. We don't need to set the IP manually, but instead it needs to receive an IP address through the DHCP server. What to do? Okay, so we'll go to that router, the client router. Okay, we'll go to this client router. We'll go to that interface, specific interface fast internet 0/0, and previously we used to give the IP like this, IP address, then 192.168.10. whatever the IP, then the subnet mask will give that. Instead of that, instead of giving it manually, we want to receive it via the DHCP. So we'll go to the interface, we'll mention it like this: IP address DHCP. Okay, now again let me capture the packets, guys, so that I can show you the discover packets and all. Okay, yes. So here let me go back to the router. So IP address DHCP. Then we have to make this interface up by giving it no shutdown. So what happens is that, say this router, okay, this router will start sending a DHCP discover. So the DHCP discover, these messages, the discover, offer, request and acknowledgement, these are usually the broadcast messages. At layer 2 and layer 3 you will have the broadcast. Okay, the destination will be the broadcast. So it will be sent to everyone, the discover will be sent to everyone, and say the DHCP server will receive it and he will send back an offer. He will send it to everyone and it will be received at the client router, and the client router will send back a request and they will receive back an acknowledgement, and then the client router will be using that IP address. Clear? Shall we check it, guys? So when you check the router, okay, so you can see, yes, the interface fastnet 0/0 assigned DHCP address 192.168.10.3. So this interface fastnet 0/0 has been assigned with an IP 192.168.10.3 from the DHCP. To check it, you will check it like this: do show IP interface brief. You can see 192.168.10.3 is assigned for fastnet 0/0. Clear? And the method is via DHCP. Okay, and if you check the packets here, you can see the DHCP. You can see the DHCP packets. So the discover, offer, request and acknowledgement. And you can see at the layer 3, you can see everyone is a broadcast here. Everyone is a broadcast. And if you inspect each packet at layer 2 also, you can see everyone is a broadcast. Okay, so the layer 2, the destination, you can see it's a broadcast. The discover, it's a broadcast here. Okay, just give me a moment. Oh, let me expand it. So here you can see the destination is a broadcast. The discover, for discover it's a broadcast, for offer also it's a broadcast, for request also it's a broadcast, and for acknowledgement also it's a broadcast. Okay, yes. Now when you check the offer will say this one. Say, let me tell you. So here the DHCP package will be like this. You will have a DHCP header, and then you will have a transport header, then you will have a network header, then you will have a data link layer header. Okay, so the transport header, in the transport layer it uses UDP, so they will be having UDP header. Okay, so this is the DHCP header, and in the DHCP header, so I told you the destination MAC and the destination IP both will be broadcast. Okay, then in the network layer you got a field called protocol field. The protocol field, the value will be 17, which says it is okay, let me show it to you. Here the protocol field, here the value is 17, which says it is UDP. Okay, then again when you check this UDP, say the source port number and the destination port number will be there. That means in the UDP header you got a value source port and destination port. So the client uses the port number, say 68. Okay, so the client uses the port number 68 and the server uses the port number 67. Okay, so this message is sent by the server to the client. So the port number, source port number will be the server's port number, which is 67, to the port number 68, which is used by the client. Clear? Now in the DHCP header, this is an offer message. In the DHCP header, let me tell you, okay, when you take it, you can see the IP address and the related parameters. Okay, I told you in the offer message they will offer certain IP address, and the offered IP address is this one, your IP or your client IP address, which is 192.168.10.3, and you can see along with that they will be giving, yes, this one, the subnet mask. okay, which is 255.255.255.0/24. Then you can see the router. Okay, so the router means the default gateway, which is 192.168.10.1, and the DNS IP, which is 192.168.10.100, and the domain name, which is cisco.com. Clear? So these are the related parameters. Got it? Okay. Now yes, so the router has received an IP address here.
What is the lease time for this?
Lease time will be, by default it will be 86,400 seconds. Okay, 86,400. So that also will be there here, the lease duration. Okay, the lease duration means, say this IP address will be leased. Okay, leased for a particular time. Okay, it is leased for this 86,400. That means 1 day, the lease duration. Okay, yes. Now this is how you will get the IP. Now guys, now suppose you have got another LAN here. You got another LAN. So this LAN here. So this router is connected to another router. Okay, suppose this is R1 and this is R2. And in R2 you got another LAN, 192.168.20.0/24 network. Okay, so if at all you have some computers here. You have computers here. Now, for these computers to receive an IP address from the DHCP, what we will do is that we will create a pool in the DHCP first. We'll create a pool in the DHCP. So let me create a pool in this DHCP here. Where is it? Yes. So I'll create a pool, IP DHCP pool, then the pool name, suppose test2. Okay, as another pool name. Then we'll be giving the network. Then what is the IP address here? So the IP address needs to be 192.168.20.0/24 range. So we'll be giving the network 192.168.20.0. Okay, fine guys. Okay, so this is 192.168.20.0, say 255.255.255.0. Okay, now so here we have got the network. We have mentioned the network, and for these computers this gateway address should be 192.168.20.1. So we'll be giving the IP address, the default router, which is 192.168.20.1. okay, then we'll be giving the DNS IP. The DNS server, suppose it is 192.168.10.100. The entire organization may have a single DNS, or maybe some other DNS will be there. Okay, so now the DNS server is also mentioned. Okay, then you can give the domain name as well. The domain name, let it be, say suppose cisco.com itself. You're working in Cisco itself. Okay, now if it's in a different LAN, if these computers are in a different LAN, the problem is that, say whenever these computers send a broadcast, the discover message, right? So the discover is a broadcast, and the broadcast will reach only up to the router R2. It will not be, say, all this discover message will not reach the DHCP server. So we have an in-between router which needs to act as an agent. It needs to act as an agent. Who is an agent? An agent is one guy who will act as an intermediate between two guys, right? So this agent, when he is receiving the broadcast, the discover message or the broadcast, he needs to convert it to the unicast and send it to the DHCP. Clear? So unless and until this relay agent or the relay agent helps, so this machine is called the agent, or it's called a relay agent. Okay, the one who acts as an agent, or the one who converts the the broadcast to the unicast and send it to a DHCP. That one is called the relay agent. So unless and until you have the relay agent, this discover will not reach the DHCP, right? So there needs to be, or we need to configure this router as a relay agent. So let me tell you, so if you want to configure this as the relay agent, what you will do is that you will go to that interface, the interface which receives the discover message, the broadcast message. That means the fast internet 0/0. So we'll go to that relay agent, we'll go to that interface fast internet 0/0, and we'll give it like this: IP helper -address. Then we'll give the IP address of the DHCP server, which is 10.28.1.1. Okay, so here we'll give the IP 10.28.1.1. Clear? So did you understand why we give it like this? Why it is necessary to give it like this? Because say here, whatever this computer is sending, right, whatever the discover package the computer is sending, that will not reach the DHCP, because that's in a different network, or that's in a different broadcast domain. So this has to be configured, this router has to be configured with a mechanism called relay agent. If it is configured with a mechanism called relay agent in its interface, whenever he receives a broadcast in that interface, he'll convert it to unicast and will forward it to that respective to the respective DHCP. Clear? And that is why it is necessary to configure this router as a relay agent. Got it? Okay. Now what happens is that if we have configured this relay agent, what happens is that the computer will send a broadcast, and what this relay agent will do is that I told you he will convert the broadcast. Okay, so previously I told you this discover packet at L2 and L3 it will be having a broadcast. Okay, the L2 it will be having FFFF.FFFF value, and at the L3 it will be having 255.255.255.255. Now the relay agent will convert it to unicast. At that time, say the source IP will be this IP, the relay agent's IP, which is 192.168.20.1, and the destination IP will be, say, the DHCP's IP, which is configured in this interface. It is configured with 10.20.1.1. Okay, so it will be sent to 10.20.1.1, which is the DHCP server's IP. Clear? So here, let me close these things and these Wireshark. Okay. Now, let me capture these packets. Start capture. Okay. Now, what we shall do is that from the PC, I am requesting an IP. Okay. So let me go to PC2. Let me go to PC2 and execute the command IP DHCP. If I execute it, it's sending the discover. It is sending a discover. Okay, and this discover, when you check the packet here, you can see the DHCP discovers here. These are the DHCP discover. So you can see the DHCP discover packets are having the source IP. I told you the source IP here will be 192.168.20.1, and the destination IP will be 10.28.1.1. It's a unicast packet. This is a unicast packet. Clear? So now he is not receiving any offer back, because so whenever the DHCP server, so I told you for the discover packets, the source IP for the discover packets, the source IP will be 192.168.20.1, and the destination IP here will be 10.28.1.1. Now it has reached, it might have reached the DHCP server. Of course it has reached, because we have captured the packets here in this link, and this router have received this discover packet. Now say what happens is that the DHCP will receive this discover packet. and we have configured the DHCP with a pool of this range, of the range 192.168.20 dot range. So he'll be ready to give an IP address from the pool. But here the DHCP should know where this network is sitting. The router needs to be configured with the routing as well. If it is configured with the routing, then he knows where the 192.168.20 dot network is sitting. Clear? So we'll configure the routing also in the DHCP. So let me configure the routing here in the DHCP. Suppose IP route, say 192.168.20.0 network, and 255.255.255.0, and the exit interface, or you can give the next hop IP, which is the 10.28.1.2. 10.28.1.2. Okay, now again, if at all we check it, suppose that again I am trying to get an IP address from the DHCP. We'll see what happens. Still issue. Okay, just give me a minute. Ten dot 28.1.2. 20.0. Just give me a minute, I do show IP route. 192.168.20.0/24, 10.20.1.2, 10.20.1.0. Yeah, subnet mask ought to be, let me check it here. Do show run pipe section fasten at or 0/0. Yes, the subnet mask is right. Okay, maybe it has to be. Now let me check one more time. Okay, and let me take the packet capture also, guys. Okay, yeah, he is getting an offer. Yeah, what happens, let me tell you. Okay, so let me take this offer. Okay, if we take this offer, you can see this. Okay, he's assigning an IP, so everything is fine here. Yes, so the problem is that this computer is sending a broadcast. Okay, okay, so this computer is sending a broadcast, and this broadcast will be converted to unicast by the relay agent. So it gets converted to unicast, and the discover is sent to the DHCP. Now the DHCP is now assigning an IP address. So we configured the range 192.168.20.0/24 range, and the DHCP is now assigning an IP 192.168.20.1, which is the first IP. But 192.168.20.1 is already there here, right? So that's the problem. So here you can see in the offer. See the offered IP address, it is 192.168.20.1, which has to be excluded because we already have an IP address here, right? So it needs to be excluded. So here, to exclude that, we will go to the DHCP again, and we'll mention it like this: IP DHCP excluded hyphen address, which is the excluded address 192.168.20.1. Okay, now it will be excluded. So now if PC2 is sending a discover, it will get another IP 192.168.20.2. Okay, we'll see this. Still issue. Let us check it one more time. Okay, cannot find the DHCP server, so let me take the capture here again. Okay, so I stopped it, guys. Just give me a minute again. Stop capture. Now this time also we'll check what is the issue. Just give me a minute. The packet is not getting captured. Just again one more time. Okay, now it's working. So now let me check the still it is getting an offer. Okay, but let us check. Relay agent, the client IP address is 192.168.20.1. 192.168. And one more thing. Do show. So now guys, I will troubleshoot it. Okay, just give me a moment. In the meanwhile, I'll be telling you some commands also. So to say we have configured the pool in the DHCP. To view the pool, you have the command show IP DHCP pool. From this command you can see the pool here. Okay, so the pool, we have created two pools here which are of the range. Here you can see the first range is test pool. So the test pool says this, the range is 192.168.10.1 to 10.254 and two leased addresses are there. Two addresses have been leased. One is leased to this computer and another is leased to the router. Okay, now the next one. So the test 2 says, say here the network is, which is the network 192.168.20.2 is the current index, and 192.168.20.1 to 254 can be assigned, and one is leased. Okay, so now to see the leased addresses, you can execute the command show IP DHCP binding. Show IP DHCP binding. Okay, you can see this. So 192.168.10.2 and 192.168.10.3, these are assigned to these machines, and 192.168.20.1 is assigned to this machine as well. Clear? Okay, now so here this is the problem because it is already assigned. Okay, so now clear, just give me one thing, IP DHCP subnet, say suppose star. Okay, just one moment. So, or I can just keep another computer here. Okay, so here what happened, I'll tell you. And connected. Okay, now let me turn on this device. Start console. Okay, now IP DHCP. Yes, this computer has got an IP address, you can see. Okay, this computer now has got an IP 192.168.20.2/24. Okay, so when you take a look at the capture here, okay, the DHCP, okay, so the discover, offer, request and acknowledgement, everything is unicast here. You can see previously it was a broadcast, now it's a unicast. Okay, so the discover and the request, these are sent by, say, this one 192.168.20.1. okay, here this request also sent by 192.168.20.1, which is the router's interface. Okay, now then the offer and the acknowledgement, say that is sent by which one? The DHCP server. Clear? Okay. Yes. You're having class there?
No, he messaged late. So messaged late that he will come.
Okay.
He will take class online.
Okay. Nice. Got it, guys? Okay. Now, and the reason behind why you didn't get the IP address for this computer. So we have been trying hard to get the IP address for this computer, right? This existing computer. The reason why he didn't get the IP was, say, for the first time, he has asked an IP and the DHCP server gave him an IP. What is the IP? 192.168.10.1 he has given it. Yeah, 20.1. 20.1 he has given it to him. But relay agent, he understood it's his own IP and then he didn't give it. Okay, so but still the DHCP thinks I have given him the IP. So whenever we send the broadcast here, say the DHCP will be thinking like this: hey, I have already given you the IP, why are you still sending it? And he'll be assigning the same IP to him. Getting it? So that's what happened. So if at all that's happening, then you can release it. You can go to the computer and you can give something like this. Okay, say the command is something like this. You will go to the command prompt of the device, CMD. Okay, and you will give the command like this. First you will release it. Okay, the command was, even I forgot,
ipconfig release, ipconfig renew.
okay, is it ipconfig? Nope, I don't think. Are you sure?
Yep.
Okay, then maybe you can test it later. Now that I'm not gonna test, because if at all I do it, my IP will be gone and my communication will also be gone. Okay, so ipconfig /release. Okay, then we will renew the IP address. IP address /renew. Okay, ipconfig, you need to test it. Okay, so we'll release it and we'll renew it. Clear? Okay. So this is the thing. Any doubt? Again, Narish. Okay, I always get the name Nishant. Okay. So again, God, forgot their name. What is his name? Kevin. Yes, there. Satish. Okay.
How to configure server?
Server. The DHCP server.
Yeah.
The DHCP server's configuration I told you.
Particular server.
Particular means you have a separate server itself. Okay, if you have a separate server, say if you have, say, the Microsoft Windows server and all, what you will do is that, say, you will install, that's not our thing, but still we'll install certain services in the this server. Okay, so install certain DHCP service is there. Okay, when you take the server manager or something, I really forgot, I studied that MCS and all years back. Okay, so you will install the DHCP service in that. It's just as if installing a software kind of thing, you know. So you will go to the server manager and you will add some features, and then you will go on clicking those things. If you have some other server, then even my previous company was a DHCP server itself. They used to work in the DHCP server. So there they have the dedicated DHCP service itself. They have the dedicated DHCP service plus DNS service, which will be automatically, which is already enabled. You don't have to enable it. Okay. So though this is the thing. Yeah.
If you are connected to the client router.
If you are connected to the client router.
Devices are connected to the client router.
Hmm.
Then how can they will be applying the IP address from this client router?
We can check it. No worries. Say if we have a client router here. This is the client router. Okay. And suppose we have, say, we will, okay, let it go. So suppose that we have a switch. Oh, I suppose, just give me a minute, guys. Okay, it keeps on coming. So you can test it today. You can go to your home and you can test it today. So you can have a switch here. Okay, you can have a switch and you can have some computers. Okay, and here you can enable the, say, this one, the relay agent, DHCP relay agent, and check whether, say, again you need to create a pool. You need to create a pool and you need to, say, mention in the DHCP about this network as well. Okay, then whenever this computer is say sending something, it will be, or I mean the broadcast when it is sent, then this router, what he will do is that he will convert it to unicast and will send it to the DHCP. Clear? Test it today, do it as a homework. Okay. Yes. Now guys, okay, so this is the DHCP. Fine. Okay, now what we are going to do is, just give me a moment, let me turn it off, or else it will be a problem here. Okay, it will take some time, let it be there. So now we are going to study a different thing that is called DHCP snooping. DHCP snooping. Okay, so now here, now let me just create again, let me just take some computers. Okay, these computers, let it be connected, let us connect it to a switch, and let us connect it to a router, and this router is a DHCP router. Okay, so now just give me a minute. Okay, so here I'm gonna assign the IP. Again, okay, suppose I am assigning in the IP here with the packet tracer. Just give me a minute guys. No, seems it's stuck. Just give me a minute. Okay, suppose that I am assigning an IP of the range like this. Okay, 192.168.10.0/24 range, and here .1, and here all the computers. Then here we'll be configuring this router with the DHCP service, and then this computer needs to get an IP address from the DHCP. Okay, so now what we are going to do is we'll go to the router, say interface, which interface it is, gig 0/0/0. So interface gig 0/0/0, IP address is 192.168.10.0, 255.255.255.0, then no shut. Okay, 10.1, yes, exactly. And then we'll be giving no shutdown, and let me configure the DHCP also. IP DHCP pool, say test, then we'll give the network 192.168.10.0. say either you can give the subnet mask or you can give the prefix length as well. The prefix length here it is not supported, so 255.255.255.0, and default router 192.168.10.1, and the DNS server, suppose it is 192.168.10.100, and suppose that's it. Okay, and IP DHCP excluded address 192.168.10.1 and 10.100, suppose. Okay, now the computer should receive an IP address. We'll cross check that. Okay, yes, you can see the DHCP is successful. He has received the IP address. The computer has received the IP address 192.168.10.2, and similarly these computers also needs to receive an IP address. Okay, so here also, and here also. Okay, so here also you can see it has received an IP 192.168.10.5. okay, so the DHCP. Now, so here I told you we'll be studying about DHCP snooping. In DHCP snooping, or DHCP snooping is used to avoid two types of attacks. It's a security mechanism. It's a security mechanism implemented in the switches, and it is used to avoid two attacks. The first is called DHCP spoofing. What is it? DHCP spoofing. And the second is called DHCP starvation. DHCP spoofing and DHCP starvation. So let me teach you what is DHCP spoofing and DHCP starvation attacks. Okay, DHCP spoofing means, suppose if this is the computer, this is a computer, and this computer is where the hacker is sitting. This is where a hacker is sitting. Okay, so now these, say you got a DHCP, and the DHCP will give the IP address to all the computers, right? So if at all this computer is sending a discover, he is sending a discover. So this discover, it's a broadcast, will be sent to all the interfaces, including to hacker, including to the router also. When it is sent to the hacker can install certain softwares, or the hacker can craft, and using that softwares he can craft certain fake DHCP offer packets, and he can send it to this machine. Okay, so this hacker is acting as a DHCP, a fake DHCP server. And that process, or that attack where this hacker is acting as a fake DHCP server, that attack is called DHCP spoofing. Okay, and let me tell you what is DHCP starvation. Okay, so suppose this same hacker, suppose this hacker is having lot of softwares in his computer, and he can craft fake DHCP discover packets. Fake DHCP discover. He will be sending multiple discover packets, and this discover will be sent to the router, and the router, being the server, the DHCP server, will think these are the legitimate discover packets, and he will be assigning he will be giving all the IP addresses to these fake DHCP, the fake DHCP, say, discover. Okay, so as a result, all the IP addresses in the server will get used up, and the server will not have any more free IP addresses. The problem is that if at all a genuine computer is sending a discover, now the router does not have any free IP address, so he is starving to give the IP address to the computers, and that is called DHCP starvation attack. Getting it? So you got DHCP starvation and DHCP spoofing, and this can be avoided by using the DHCP snooping. Clear? So now, shall we do the DHCP? Yeah.
So the DHCP server will send DHCP decline message, right?
DHCP server.
I mean, like when the pool is exhausted and the new host is discovering, like,
yes,
for a new one.
Yeah, they'll be sending that. Okay. So those are some other messages, right? Okay. Now, so here what they will do is that we will configure this one. Okay, we will configure here the DHCP snooping in the switch. The DHCP snooping will be configured in this switch. So to configure that, we'll go to the switch and we'll execute the command like this. So IP DHCP snooping. Okay, and then we'll we'll execute one more command, IP DHCP snooping VLAN 1. Okay, so we have implemented, or we have enabled the DHCP snooping in the switch. At this time, what happens is that if at all you have the hacker, here. Okay, if you have the hacker, and if at all this computer is sending a broadcast here, or a discover message, So this discover message will be sent to everyone, including the hacker, including the correct or the legitimate DHCP server. Now the hacker also will send an offer and the legitimate DHCP will also send an offer. But this offer will not be accepted. This offer will not be accepted. As a result, this computer will not get an IP address. Shall we check it? Okay, so see when we go here. So here what I'm gonna do is I'll give static and I'll give DHCP. So he's sending a discover and we'll see he'll not get back an offer. So you can see this, you can read it. DHCP failed. APIPA is being used. APIPA means automatic private IP address. So if at all the computer didn't get an IP address from the DHCP, they will automatically assign an IP address of the range 169.254 range. And that range is called APIPA. Clear? Okay. Okay. So now, this computer will not get an IP address. Not even from the real DHCP also. He'll not get the IP address from the real DHCP. Because by default, say I told you if at all the offer is sent, right? The offer, so the DHCP snooping. The DHCP snooping I told you is a security feature. And whenever he receives an offer message through the untrusted port, then he will not accept these offer message. Okay, by default all the interfaces are untrusted port. Even the interface in which the real DHCP is sitting, that is also considered as untrusted port. So if at all they are receiving an offer message through the untrusted port, they will not receive it. They'll say discard it. Okay, because they are receiving the offer from the untrusted port. You cannot trust it. The offer message received from the untrusted port cannot be trusted. So what if the computer needs to receive the offer? If he needs to receive the offer, this has to be made as the trusted port. This has to be made as the trusted port. And what is the advantage if you make it as a trusted? If you make it as trusted, then if at all the legitimate device is sending an offer, this offer is received via the trusted port, then it will be sent to the computer. Whereas, say this interface, suppose F0/10. So this is still, it's an untrusted. So even if the hacker sends an offer, it will not be sent to the computer. So this is how you will say avoid the DHCP spoofing attack. Clear? So now let me make this interface as trusted port. To make it as trusted port, we'll go to that interface. Interface FA0/5. And we will give the command like this: IP DHCP snooping trust. We'll give the command as IP DHCP snooping trust. Clear? Then what we are gonna do is we are gonna do one more thing. So when you configure this switch as the DHCP snooping. When you configure the switch with the DHCP snooping, this switch will act as a relay agent. It will act as a relay agent and will add certain options to it. So you have to disable that. To disable that, you will go to the switch. You will go to the switch and you will mention it like this. So no IP DHCP snooping information option. So this is the command that you will give: no IP DHCP snooping information option. So when you give this command, they will not be acting as a DHCP relay agent. Clear? Now when you check it, when you go and check, this computer will receive an IP address. Here you can see now the DHCP request is successful. This computer has received an IP 192.168.10.5 and the related parameters also he has got it. Clear? So this is how you will configure the DHCP snooping. Okay, now so I told you the DHCP snooping will avoid DHCP spoofing and also the starvation attack. So I told you starvation attack, say this hacker, suppose this hacker is there. This hacker, when he is continuously sending the discover, okay, so that's the starvation, okay, that causes the starvation attack. So if at all you have the hacker here, suppose you have the hacker, okay, and this machine is connected here. Now, so to avoid the starvation attack, what we are going to do is, okay, you can set a limit rate here. You can set what? Limit rate. Okay, so in the starvation attack, when the starvation attack occurs, okay, so this hacker will be sending lot of packets, maybe 1000 DHCP packets he will send it per second. He'll be sending 1000 DHCP packets per second. So to avoid the DHCP starvation attack, you can set the limit rate. You will set the limit rate. So the limit rate can be like this. Say you can set it like 2 packets per second. If you set 2 packets per second, in 1 second, this interface can only accept 2 DHCP packets. If at all, say he receives 3 packets per second, then it will be, say, made down. The interface will be made down. They will detect it as, or they will think that it is a starvation attack, and that the interface will be made down. Okay, so shall we set the limit rate here? Okay, so to set the limit rate, we will go to the respective interface. Okay, so we'll go to the respective interface here. Okay, interface FA0/6, and we'll set it like this: IP DHCP Snooping limit rate. Then we'll give the packets per second. So suppose that I'm giving 2 packets per second. Okay, 2. Okay, then suppose that I'm trying to send multiple DHCP packets. Okay, I'm trying to send multiple DHCP packets like this. Okay, again, just give me a moment. Okay, so now you can see this interface has gone down. Okay, you can see it has gone down because here you can read it. Say DHCP Snooping received 3 DHCP packets on FA0/6. Now DHCP rate limit error detected on FA0/6, putting FA0/6 in error disabled state. So it has been made down here. Clear, guys? So now if at all it is down, what you can do is you will make it down and then you will make it up. Okay, this is how you will make this interface operational. Again, any doubt in this one? So this is the DHCP Snooping. Okay, now if you configure the DHCP Snooping, so now let me just again one more time. Okay, so if you configure the DHCP Snooping, now, so the DHCP Snooping will maintain a table called binding table. Okay, to view that table, the command is show IP DHCP in the switch. Show IP DHCP, say Snooping binding. Okay, you can see the binding table here. It shows the respective MAC addresses along with the IP addresses, along with the lease duration, and along with the interface also. Okay, so you can see the MAC address, so and so MAC address is having so and so IP address, and he is sitting in FA0/4. And this MAC address is sitting, say he is having an IP 192.168.10.4 and he is sitting in F0/3. These information will be there in the DHCP binding table. Clear? Suppose we got a binding table like this. Okay, so the binding table here, okay, so let me draw the binding table here. Just give me a moment. So this, suppose the PC4, okay, PC4 is having the MAC4 here, okay, and he is having, suppose, consider that he is having the IP.4 192.168.10.4. 10.4. And he is sitting in F0/6 now. F0/6. And PC0 is having MAC 0. And suppose he is having the IP 192.168.10. Say 3 or say 10. Okay, and he is sitting in FA0/1 here. And PC1 is having MAC 1 and he is having the IP 192.168.10.20. Suppose these are the IPs, and he is sitting in F0/2. And PC2 is having MAC 2 and 192.168.10.2 he is sitting in F0/3. And PC3 is having MAC 3 and 192.168.10.3 he is having, and he is sitting in F0/4. So this is the DHCP snooping table or the snooping binding table. Okay. Now we are gonna study one more thing here. Okay, one more security feature which is called dynamic ARP inspection. What is it called? Dynamic ARP inspection. Okay, which is or DAI, dynamic ARP inspection. Which is used to avoid another attack, which is called ARP spoofing. It's called ARP spoofing. Okay, now let me tell you what is ARP spoofing. You know what is MAC spoofing, or say this one, what is it, DHCP spoofing, right? Now ARP spoofing. What is ARP, guys? Address Resolution Protocol. It is used to find out the MAC address of a device using the IP address. Okay, suppose PC4 or suppose PC0. PC0 wants to find out the MAC address of PC3. PC0 wants to find out the MAC address of PC3. So he knows the IP address of PC3. The PC3 is having the IP 192.168.10.3. Okay, so he'll be sending, say, the ARP request here. ARP request will be sent, and ARP request says who is having the IP, say who is having the IP 192.168.10.3, and I need to know your MAC address. Clear? So this PC3 has to reply back, hey, I am, so he will reply back with ARP reply, and he'll tell like this, I am having the IP address 192.168.10.3 and my MAC address is MAC 3. He will send the ARP reply. Clear, guys? Okay, so this is the usual thing. Now talking about the ARP spoofing. So this, suppose PC4 is where the hacker is sitting. Okay, so hacker, say whenever the ARP request is sent, ARP is this request is a broadcast. It will be sent to all the interfaces. It will be sent to all the interfaces, including the hacker's machine. And now hacker, what he can do is he can craft certain ARP replies. He can craft certain ARP replies. It's not a genuine ARP, it's actually a fake ARP that he is creating. He is claiming to be the MAC 3. His MAC address is MAC 4, but he is claiming to be MAC 3, or he is claiming to have the IP address 192.168.10.3. Okay, so he will reply like this, I am 192.168.10.3. I am 192.168.10.3 and I have the MAC address MAC 4. Clear? Okay, so this is the faked ARP message. Okay, so this is the ARP spoofing. This hacker can send the fake ARP replies, and this process is called, this attack is called ARP spoofing. To avoid ARP spoofing, I told you we will do the dynamic ARP inspection. Now, if you do the dynamic ARP inspection, so it will avoid the ARP spoofing by checking onto the, say, this table, the ARP, or say the DHCP snooping binding table. So it will check the snooping binding table, or it will seek the binding table's help to avoid the ARP spoofing. Shall we check how? Yes or no? Okay, so whenever the ARP replies are received to the switch, whenever the ARP replies are received to the switch will check the snooping binding table. So whenever this hacker is sending, suppose the hacker is sending the crafted ARP replies. So the ARP reply is containing the IP like this, IP 192.168.10.3 and MAC4, he has received it via F0/6 interface. Okay, so whenever he is receiving the ARP reply via F0/6, he will check it. So the MAC4 of course, MAC4 is sitting in F0/6, but he is not having the IP 192.168.10.3, but he is having the IP 192.168.10.4. So this is a fake ARP message. He'll understand it's a fake ARP message and he'll not allow this ARP message to send back or to be sent to this PC 0. Clear? This is how they will avoid the ARP spoofing. Clear? Now, what if this legitimate machine is sending the ARP reply? If this correct machine or the genuine machine is sending the ARP reply, it is received to F0/4 and it says, the ARP message says, I'm having MAC3 with the IP address 10.10.3. So he will check, yes, MAC3 is sitting in F0/4 and he is having the IP address 192.168.10.3. So it's a correct entry. So this is the correct ARP reply. So it can be passed to PC 0. So the correct message, the correct ARP reply will be passed while the fake ARP replies will be blocked. Clear? So this is the concept of dynamic ARP inspection. Any doubt? Clear, guys? Okay. So to enable the ARP inspection, we'll go to the switch and we'll mention the command like this: IP ARP inspection VLAN 1. Yeah, enable the ARP inspection. Clear? Okay. So this is the ARP inspection. Any doubt? Okay. I hope you have understood. Clear? Okay. So then we'll take a small break and then we'll continue with the next topic. Okay, so next topic, what I'm gonna go is, see here, just so this is completed. So then we'll go with small theory portions and all. Okay, so I'll go with SSH. I suppose we haven't completed, right?
Yeah.
Okay.
Secure
Secure
shell.
shell. Okay, secure shell, it's not completed, I suppose. Okay, or we'll go with the theory. Okay, we'll go with some QoS, this traditional versus SD, and all these kinds of theory portion, the WAN protocols and all. Okay, yes, after the break. So we'll take a break till 9:30. We'll get back at 9:30. Okay, yes. So guys, shall we start?
Yes.
Okay. So now we'll go with some theory portion. As I told you, we'll go with WAN protocols, MPLS, these one first. Okay. So you can write WAN and WAN protocols. Okay. Just some basic things, that's it. So WAN, or it's called wide area network. Wide area network. Now, so if you have, say, two LANs here, suppose you got a branch, say this is the Delhi branch and this is the Bangalore branch. If you got Delhi branch, you will have a LAN here, right? So you will connect to the switch and then you will connect to the computers. Okay, so you can connect this to a switch, then to multiple computers. This is the Delhi branch. The same thing in the Bangalore branch, you can connect a switch and you can connect to multiple computers. To two LANs, to connect between two LANs which are geographically separated, we will go with the WAN connectivity. We'll go with the WAN connectivity. So here from Delhi to Bangalore, we do not have the authority to lay the cables. So we will approach, yes, the service provider. We'll approach the service provider. So when you approach the service provider, you will tell, say, hello service provider, say I've got a branch in so and so location in Delhi and I've got so and so branch in so and so location in Bangalore. I want to connect these two, and they will give you certain options. They'll give you certain options for leased line connection. They'll give you certain options for cable modem connection. They'll give you certain options for DSL connection, ADSL connection. Lot of connection mechanisms are there. Okay, so these are the WAN protocols. Okay, you can go with a leased line. Okay, so the company, almost all the companies uses leased line connection only. Leased line connection. In the leased line, what they will do is that they might have already laid the cables. Okay, and what they will do is that they will give you that cable. Okay, so through that cable or through that line only you will be sending the data, or they got some mechanisms where your data will be, say, sent separately, or your data will be sent securely without anybody else accessing it, and that is the leased line. So they will lease you a line, and in that line only you will be sending the data, and that much secure it be. Okay, so the companies will opt for something called leased line, or leased line is also called dedicated line connection. Dedicated line connection. Dedicated line connection.
So it will be flowing through cables.
Yes, can be cables, can be, say, now wireless connection also you can do. Okay, wireless connection also it supports. Okay, now, so here this is it. Now talking about the WAN. Okay, suppose that R1 router is there. Now here you have got a WAN standard, suppose the serial standard. Okay, the serial cable here also you have the serial cable. Okay, now so this is the WAN standard, WAN, and this is also the WAN standard. Okay, now here suppose you got a, say, a fast internet 0/0, and here you got a switch and you got some computers. Here also you got a switch and you got some computers. So here we use the fast Ethernet or the Ethernet technology, and Ethernet technology is a LAN, local area network, a LAN. Okay, so here also it's a LAN, suppose fast internet 0/1. Okay, so now if the computer 1 is sending something to computer 2, if computer 1 is sending something to computer 2, okay, so what happens is that the packet will be having the source IP will be the machine 1's IP. Okay, and the destination IP will be machine 2's IP. Okay, now then while coming to the data link, suppose while coming to the data link, so in the data link or in the layer 2, so which protocol is used in the layer 2? Here we use Ethernet standard. We use Ethernet standard, or the Ethernet protocol is used in the layer 2. So what we will do is that in the layer 2 they will have a layer 2 header and a layer 2 trailer. Okay, and in the layer 2 header it is the Ethernet header and it is the Ethernet trailer. So in the Ethernet header only you will have the source MAC and the destination MAC. Source MAC and the destination MAC. So the source MAC will be the MAC address of this machine. And the destination MAC, what will be the destination MAC, guys?
By ARP resolution. By ARP it will.
By ARP it will get it. But what will be the destination MAC here? Whether it will be the MAC address of the second machine? Yes or no?
Yes.
Yes. Then that is wrong. Let me tell you. Yes, exactly.
The router MAC address.
Yes. It's not the MAC address of the machine 2. But it is the MAC address of the fast Ethernet 0/0. Is a MAC address of fast Ethernet 0/0. Okay, so let me tell you, if at all the MAC address is not known, if it is unknown, I've taught you they will send the ARP. So ARP is a broadcast and all I've taught you, right?
Yes.
So if at all the destination MAC is not known or unknown, the computer will be sending the ARP request. So ARP request, it is sent to find out the MAC address of this fast Ethernet 0/0, not to find out the MAC address of the computer 2. Getting it? Okay, let me tell you an example here. Okay, let me tell you an example. A similar, it's a non-technical one. Suppose you're traveling from, say, Bangalore. Okay, or you're traveling in Bangalore, you are now in HSR layout. You are now in HSR layout. And you want to say go to, say, suppose UK. Okay, UK you need to go specifically to Westminster Abbey, suppose. Okay, so what you will do? So you will, from here you will board the, say, cab, right? And say when you're going or so here this is the Bangalore airport. This is the Bangalore airport. Okay, and now this is UK airport. Okay, so from HSR layout you will board a car, and while boarding a car, say you will tell the destination. What is the destination? You will not tell Westminster Abbey is not the destination. You will, at that time you will tell, okay, Bangalore airport is the destination. Clear? Actually, say your journey is from HSR layout. Okay, your journey is from HSR layout to Westminster Abbey. Okay, or suppose your home, say this is your home, to suppose your office. Okay, so your destination at the L3 it will be, say it will be same. So you are going from your home to, so the home is the source and your office is the destination. Okay, now but when you board the taxi, then you will tell, you will not tell I want to go from my home to my office. You will not tell like that, but instead you will tell the source is, where is the source? HSR layout. HSR layout is the source. Now destination, I'll be telling Bangalore airport. So I'll be telling Bangalore airport. Now I have reached Bangalore airport. So still my destination, say this packet, the inner packet, it remains the same. Right, I want to go from my home to my office. But from the Bangalore airport, suppose you are going for the security check-in. So at that time, say suppose a security has asked, or say the person has asked you, say from where you are going to where you are going. At that time you will tell, from Bangalore airport I am going to UK airport. Okay, so at the layer 2, so it will be, say the Bangalore airport, the source will be Bangalore airport to destination will be UK airport. Getting it? Now once you reach the UK airport, and again you will be taking another taxi. At that time what you will be telling, the source will be, say the source will be UK airport. I am boarding a taxi from the UK airport and I am going to Westminster Abbey or so and so, say address. Clear? To your office. Okay, so the inside this packet content remains the same. The packet content remains the same. So here also the packet content remains the same. Okay, so throughout the journey, the packet content remains the same. The source IP. So here also the source IP will be the first machine's IP, and the destination IP will be the second machine's IP. Clear? Now, but the data link layer header and the trailer changes. Okay, let me again tell you the real thing that's happening. Okay, so say I told you that while this computer is sending the data, it is processing the data from layer 7 to layer 1. So at layer 3, they will add the source IP and the destination IP. Okay, and at the layer 2, they will add the Ethernet header and the Ethernet trailer. So Ethernet header says the source MAC is the machine 1's MAC, and the destination MAC is this fast internet 0/0 of the router 1. Clear? Now, yes, so when it is passed to the switch will check its CAM table and it will check for this MAC address, the router's 1's fast internet 0/0's MAC address. So the switch knows to send the frame to that MAC address, he will have to send this through this interface. Got it? So the switch receives this frame, or it receives the information via L1. He'll pass it to L2. Okay, at L2 he takes the forwarding decision and it is again sent through L1. Got it? Here? Okay, now again say the router receives it via L1. Now what he will do is that this is the packet structure he receives, this is the frame that he receives. Okay, now he will check the destination MAC, whether the destination MAC matches his MAC address or not. If yes, he will accept it in layer 2, then he will strip off the layer 2 header and trailer, then he will pass it to layer 3. Okay, and in the layer 3, the forwarding decision is taken. The router, suppose the router is configured with the routing and all, and he knows how to go to this second machine's network. So the router will check the routing table and will match the packet, and he will send it via this serial interface. When it is passed through the serial interface, he will pass it to L2 again. He will add the serial. So now we got this WAN here. What you got here? WAN. So he will add another header and trailer. This time it is not Ethernet header and trailer, it is another header and trailer, which is WAN header and trailer. What is it? WAN header and WAN trailer. And the WAN header and trailer does not consist of the MAC address and all, it consists of some other values. Okay, then it is passed through layer 1 as bits. Clear? Now this is received at router 2. Router 2 will receive it at layer 1. He will pass it to layer 2. He will check at layer 2 whatever is the addressing mechanism and the WAN, he will check it whether it has come for him or not. If yes, he will accept it. Okay, he will accept it and will strip these WAN header and trailer, and the packet here will be considered. Okay, he will check the destination IP. The destination IP is the second one, the IP address of the second machine, which is directly connected to this network. So he understands this network is connected to FastNet 0/1. He'll pass it to this interface, FastNet 0/1 interface, and they will add this layer 2, the Ethernet header and the Ethernet trailer. This because here it is fast Ethernet. It is of the Ethernet standard. So he will add the Ethernet header and the trailer. At that time, the source MAC address will be the MAC address of this FA 0/1, and the destination MAC will be the MAC address of this machine 2. Clear? Everyone fine? Okay, then it will be passed to the switch, and the switch will check the CAM table, right, whether the CAM table contains this MAC address or not. If it is there, he will flood it to, also he will send it to only that machine. He will not flood it, he will send it to that machine only. Clear? So throughout the journey, this packet remains the same. This packet remains the same, but in the Ethernet or in the layer 2, it keeps on changing with respect to different standards. If you have different standards, it will keep on changing. Clear? So this is what happens. Okay, now the next thing. Nowadays, so I told you Ethernet is a LAN standard, local area network, but nowadays Ethernet can be used in WAN as well. Ethernet can be used in WAN as well. So here the serial, suppose you have, say, the connection like this. This is the serial, this is the serial, and this is, suppose here you use gigabit, gig 0/0/0. Here also you use gig 0/0/0 on top. So gigabit has got a bandwidth of 1 Gbps. And this serial interface, the WAN, they have got a basic bandwidth, or the basic bandwidth will be 1.544 Mbps. So what happened was, see, this 1 Gbps is much more faster than this 1.544 Mbps, right? So then they started thinking like that, why can't we utilize, or why can't we use this Ethernet standard in the WAN also? Okay, one problem was that, say, the Ethernet, it supports only maximum length of 100 meter. So what they did was, they say converted it. So they can use the Ethernet standard here in the WAN also. Then they can convert it to different standards. Suppose they'll convert it to the optical fiber. Okay, using the SFP, something called SFP, small form factor pluggable. Using these SFPs and all, they will connect it, or they will change the standard. So now the Ethernet can also be used in the WAN. So if at all you use Ethernet in the WAN, then that is called MetroE Ethernet. What is it called? MetroE Ethernet. Clear? So MetroE Ethernet, it means you are using the, say, the Ethernet in the WAN. Clear? Okay. And again, some more theory portions are mentioned. You can read it. Okay. Now again, if you go with the WAN options or WAN topology, okay, you have different topologies. First one is called full mesh. Full mesh means if you have a headquarters here, okay, the physical connectivity. Okay, if you have the headquarters and if you have 3 branches, branch 1, branch 2, and branch 3. So if you have headquarters and branches, everyone will be connected to each other like this. Means headquarters is connected to all the 3 branches, branch 1 is also connected to headquarters and all the 2 branches, and branch 2 is connected, and branch 3 is also connected to all the branches and the headquarters. So this is the full mesh topology. Okay. And again, you got something called partial mesh as well. Partial mesh says, suppose if you got the headquarters, and from the headquarters you are connecting it like this, from branch 1 again to branch 2 again to branch 3. Okay, so you have not connected it completely. Okay, so now suppose the headquarters is connected to branch 3 like this. Now branch 1 to 2 connection is not there. It is not a full mesh connection. Okay, this is called partial mesh. Okay, now we got one more, which is called hub and spoke topology. So the hub and spoke topology, here they got headquarters, and if at all they got branch 1 here, branch 2 here, and branch 3. The hub and spoke says the headquarters, all the headquarters are connected to all the branches like this, and the branches are not connected in between. Okay, so from the hub to the spoke, hub is the headquarters and spoke is the branches. Spoke are the branches. Clear? So this is the hub and spoke topology. Clear? So these are the WAN options. Okay, now the next thing. So this is the WAN protocols and MPLS. Okay, so now let me tell you about MPLS. So I told you, you can go with, say, or you can connect to the service provider, right? So the service provider will have, suppose this is the Delhi branch. This is the Delhi branch, and this is the Mumbai branch, or say the Bangalore branch. So the service provider will have certain mechanisms. They'll have their own mechanisms to send the data. So one such service provider technology is called MPLS. multi-protocol label service. Multi-protocol label, it's not service, sorry, it is switching. Multi-protocol label switching. Okay, so now let me tell you about MPLS now. So here it consists of two parts. First is multi-protocol. It is multi-protocol. It consists of multiple, or it supports multiple protocol. Suppose from the customer edge to the provider edge. This is the customer edge and this is the provider edge. From the customer to the provider, it supports multiple connection. Suppose if you want to go with the lease line, you can go with the lease line. If you want to go with the DSL connection, you can go with the DSL, or the ADSL connection, you can go with the ADSL, or the frame relay connection. You have different frame, say the WAN connections. So you can, it supports different protocols, and that's why it's called multi-protocol. So to connect from the customer edge to the provider edge, it supports multiple protocol. Clear? Then what happens is that once you reach the provider edge, what they will do is that to the packet structure they will add certain labels. They'll add certain labels, or they'll add another headers, and this is the label here. This is the label. Okay, now then they will add the layer 2 header. So in between the layer 3 header and the layer 2 header, some labels are added. Some what are added? Labels are added. Then the provider routers, they will not forward this packet based on the IP address. They'll forward the packet based on the label. So they will check the layer 2 header and they'll check the label. They'll not check the layer 3. Okay, so that is why it is called label switching. That's why it's called label switching. And it's faster as well. MPLS is faster because the label, I suppose it is 4 bytes of label or something what they add. So instead of reading the 20 bytes header in the layer 3, they just need to read 4 bytes. Okay, so that is much more faster also. And say the MPLS supports one more thing. The MPLS supports traffic engineering. It supports traffic engineering. It means if at all you have congestion, then the packets will be automatically redirected through another path. It will get automatically redirected through another path using a protocol called RSVP, reservation protocol. Okay, so these are the MPLS, multi-protocol label switching. And one more thing, MPLS is also called layer 2.5. It is also called layer 2.5 because the label is added between the layer 2 and the layer 3 header. It is also called layer 2.5. Clear? So this is the MPLS. I hope you have understood. Okay. Now the last one for today. We'll wind it up faster. So this one is called VPN. Yes. Virtual private network. Virtual private network. Let me tell you what it is. Okay. Suppose this is the Delhi branch and this is the Bangalore branch. From the Delhi branch to Bangalore branch, I told you almost all the companies will prefer the lease line connection. But the lease line or the dedicated line connection, it is costly. It is costly. Then they started thinking some other mechanisms to get them connected. Then they started thinking, why can't we utilize the internet connection? So again, let me tell you, the WAN connection and the internet connection both are different. The WAN connection and the internet connection both are different. So say, of course, the Delhi branch, they will have the internet connection. Okay, so they will have the internet connection. Okay, they'll have the internet connection. So this is the Delhi branch and this is the Bangalore branch. Both the branches will have the internet connection. Okay, then why can't we utilize the internet connection to get them connected? Right. So of course this is the also a connection, right? Then why can't we utilize the internet connection to get them connected? But the problem was with security. Security in the sense the internet is a public network. Anyone can capture these packets. Whatever you send, anyone can capture these packets and can read these packets. So it was not secured. Then they started researching how they can make it secured while sending the packets through the internet. And they have come up with certain things called VPN, virtual private network. It's actually a virtual private network. It's not a private network. It is through the public network you are trying to connect from the Delhi branch to the Bangalore branch. And that is why it's called virtual private network. Okay. So what happens is that, suppose you got, say this is the computer here. This is the Delhi branch. And this is the Bangalore branch. This is the switch. And this is the switch. So now this is the service provider. I've taken the internet connection, suppose. Okay. So this is the internet connection. Suppose this is the service provider, device 1. There's another device, another device, another device, another device. Okay, here. So what happens is that, say suppose this IP is 192.168.10.1 and this is 172.16.1.1. Both are the private IP. Now say if at all this machine wants to communicate to this machine, so what will be the packet structure? The source IP will be having the IP which is 192.168.10.1 and the destination IP will be 172.16.1.1. Okay, so this is our Delhi router and this is our Bangalore router. It has reached to the Delhi router. So what the Delhi router will do is that this is the correct packet. The packet will be encrypted. The packet will be encrypted. It will be encrypted so that nobody else can read it. Okay, so it is encrypted using some encryption algorithm or encryption standard. Okay, it uses some encryption standards. So the certain encryption standards are there. DES, 3DES, AES, etc. are there. So you'll use the encryption standard to encrypt it. Okay, so yes. And then they will add new headers. They'll add new headers. Some more headers are added. For now, just consider new IP header is added. Along with that new IP header, some more headers are added. Leave it. Sorry. Now just consider new IP header. Suppose here you got the public IP which is 1.1.1.1 and here you got the public IP 2.2.2.2. It is the internet connection. Okay. So now new IP header is added and the new IP header says, say the source IP it is 1.1.1.1 and the destination IP it is 2.2.2.2. Okay, then what happens is that then they will add another layer 2 header and all. So these routers, the service provider routers, will process the packet, but they will say this is the outside or this is the another packet. Okay, so what happens is that they will process this IP header only, the new IP header only, they will process it. And they will come to know that, okay, this 1.1.1.1 is trying to communicate to 2.2.2.2. But really, inside this packet, you have another packet which is encrypted. So that packet cannot be read by, or that is not readable by these service provider or the in-between devices. Clear? Okay, so in VPN what happens is that we will encrypt the packet, then we will encapsulate it with some other headers, the new IP headers and all. So this process of encrypting plus encapsulating is called tunneling. What's it called? Tunneling. Okay, so it is as if you have created a tunnel directly from the the Delhi branch to the Bangalore branch. It is as if you have say whatever you encrypted in the Delhi branch will be decrypted by the Bangalore branch. So secretly you are sending something through the tunnel. Clear? So that is the concept of VPN. Okay, now again I'm not going into in depth of VPN, so again they'll use some key, so those things and all you can read it. Okay, now you got two types of VPN. Say the first is called side to side VPN. Side to side VPN. In side to side, what happens is that you are connecting from a single site. That means the Delhi branch to the Bangalore branch. One side to another site. One side to another site. site to site VPN. And then you got one more which is called remote access VPN. Remote access VPN. So remote access VPN, say it is, you can log in from the remote places. Suppose if at all you might have heard of work from home, right? So work from home allows you to work or get connected to the office network from anywhere in the world. Suppose if I am in US today, I can get connected to my office which is in India. If at all tomorrow I am in UK, then I can get connected to, say, this one, say the office in India. Say suppose day after tomorrow I'm in Switzerland, I can connect to the office from the Switzerland. Clear? So I am accessing it from the remote locations. That is the remote access VPN.
Accessing office means in the sense of what application?
Maybe the files and folders, maybe like the documents, maybe the videos, the training videos or whatever.
In a particular office websites?
Yes, it may not be the office website itself. It can be a particular server in which you have stored that data. Okay, so those are the things. Clear? Any doubt in VPN or any clarifications needed? Okay. Online guys, what about online guys? Alok, Lakshit, Srikanth and Vijesh.
All chaos.
Okay, everyone's fine, right? So we have completed this one as well. Okay, VPN basics also. So tomorrow we'll be completing this IPv6 and then we'll be going with these things. Okay, and day after tomorrow I hope we will complete it. Okay, day after tomorrow means Thursday. Okay, not Thursday, maybe on Friday we'll complete. Okay, we don't have much portions left. Okay, trust me, we don't have much portions left, but still I'm trying. Say usually I used to take this DHCP and the DHCP snooping and everything together in a single class, 2-hour class. Now that I've winded up in 1.5 hours and I've explained this also, so I hope that we'll complete it within Friday itself. Okay, by Friday we'll complete it. Okay, that's my plan. We'll check it. Okay, so thank you guys. We'll get back tomorrow. Thank you.
So that online MCQs, on that you send only 2 links.
2 things. Okay, let me share it today. Okay, let me pause.